Hello folks, welcome back. This is Math 2, Unit 6, Lesson 6.3. This is a continuation of the previous video going over Activity 1, circling the problem. Right now we're going to do a video walkthrough of number 2. So for number 2, the point 22.3 looks like it might be on the circle. Verify if it really is on the circle and explain or show your reasoning. So this is kind of similar to the previous question. I hope that you pause this video and try this on your own, and then you can always check your work once you're finished. So let's first start by plotting 22.3. So that takes us like right about here. I'm going to label this point B, so 22, 3. And remember last time we used concepts of radius and Pythagorean theorem, right, to test whether this point was actually on the circle. So I'm going to draw a line connecting center to this point. And there's actually a few ways that you can draw this triangle out. So if you have something different from me, but it gets you to the same end result, then that's totally fine. So I'm going to actually draw the triangle going down this way and then connecting it over here. So remember, right, we got to find what this coordinate pair is. And we can do that by looking at the x coordinate for the center, which is 6. So we know that these two are on the same line over here. So I'm going to put 6, comma, and then we know that this point and our point B are also on the same line, but this time it's a horizontal line. So we know that the y value is going to be the same. So y value will be at 3. All right, so we've got our missing coordinate pairs. Just like I did in the last video, I'm going to draw this out here below as a separate triangle. Remember, this is our right triangle. So let's first find the distance between our center point and then this like missing point over here. So I'm going to just draw this like bracket. Right, we know that they're both on the line x equals 6, right? The x coordinates staying the same. The only change here is the y coordinates, that vertical distance. So we've got 10 and 3. So we can just do 10 minus 3 to give us this distance over here. And then our horizontal distance, we have our y coordinates the same, but our x coordinates are changing. So the distance here will be 22 minus 6. Okay, so let's label our figure now. So we know that 10 minus 3 is 7. So I'm going to label that here. We know that 22 minus 6 is 16. And remember that we are always trying to solve for C in this case. And C represents our radius, right? So I'm going to put radius. And we need to prove that this hypotenuse, this C value, is equal to 17, right? That's from the first part of the question over here. This is like our important piece of information. So again, we can apply the Pythagorean theorem. So I will say that my A value is 7 and my B value is 16. So I've got 7 squared plus 16 squared equals C squared. 7 squared is 7 times 7, so that's 49. 16 squared is 16 times 16, 256 equals C squared. And then when you add up 49 and 256, you get 305 equals C squared. And then our last step here is taking the square root of both sides. The radical and the exponent cancel out. And then if you plug this into your calculator, square root of 305, you get roughly 17.5. So because, right, this C value of 17.5 is not equal to 17, which was our radius, the point 22, 3 is is not on the circle. Okay, so go back to your activity and then answer number 3 on your own and basically try to summarize the approach that we've been discussing today in activity 1. Good luck. I will see you back in the next video for activity 2.